Welcome, ladies and gentlemen, to the fifth video, part 5 of 5 of the Unit 2 test review for statistics. This covers a lot of material here and does some calculator work, so make sure you have your graphing calculator handy to follow along with me. The first thing we're going to do is do the sample size equation, because if we actually know a couple things about confidence intervals, what the standard deviation was the last time we did the survey, and how accurate we want to be, we can actually develop a pretty good sample size. Now, the formula for sample size is also on your formula sheet. And again, you will be given a formula sheet when you enter the test. You're not to use your own. And this is similar to the one that's provided by the book, and it's in your book if you've purchased it from the bookstore. This is the formula is where you take the z-score of the alpha divided by 2, multiply it by the standard deviation, and divide those two things by the e, which is going to be your acceptable margin of error that you're going to develop or given in the problem, and you square that. And most importantly, when you get to the answer, you're going to round up. So if you get an answer of like you're going to have to do 19.1 surveys, that means you're going to have to do 20 surveys, because you wouldn't want to round down to miss out on your chance of getting accurate data. So what we're going to do is find the sample size, and this is a pizza shop owner who wants to find the 95% confidence interval. So this is going to be our alpha right there. Our alpha, actually 95% is our confidence interval, so our alpha is going to be 0.05 right there, of the true mean cost of a large plain pizza. How large should the sample size be if she wishes to be accurate within 25 cents? This is our acceptable error that we're going to assume, and assume that a previous survey had a standard deviation, so this is our lowercase sigma, of 50 cents. Alright, so let's now plug this into the formula to find n, our sample size. Now the first part of the formula is z alpha divided by 2. Now our alpha is 5% since we have a 95% confidence interval, so what we're going to do is we're going to look up the alpha cut in half. And if the alpha is cut in half, we're going to look up the either 0.025 or we're going to look up, in this case, 0.9750. Now that's because we're going to take this value, whether we look up the positive or negative, once we square it, it's going to be positive anyway. So if I do the z of alpha divided by 2 for 0.9750, I get an answer of 1.96. This is our z-score for alpha divided in 2. Then we're going to multiply that by our standard deviation that we had from a previous problem given to us here, which is 50 cents, and our acceptable margin of error is 25 cents. Now if we do all of these things and then square it, we should get a sample size, and the sample size must be rounded up. Now I would also be careful, if you're to type this into the technology, you should probably follow your order of operations. So the 1.96 times the 0.50 is your numerator divided by your denominator, which is 0.25, and you should have that in parentheses 2, and then have everything raised to the second power. Now that's again if you want to do it within one string. You'd be better off probably multiplying these two than dividing by the 0.25 or 25 cents or the 25 hundredths, and then squaring the answer at the end. This will give you an answer that's approximately 15.4, but you should also say in your answer, you can't just leave it that way. You have to say, well, that means we're going to get 16 samples there. We're going to take 16 competitors, and we're going to check to see when we have what their prices are, and for what we should charge our own pizza customers. Alright, so looking on the numbers 15, this right here, 15, and this information I'm highlighting is for informational purposes. You're going to have this first part, when should you use z and when you should use t. To make it pretty straightforward, a black and white choice, you should use your z distribution if your sample size is greater than or equal to 30. And you will have a sample size on your test that's exactly 30, so you should know that it's the z-test. T distribution is when your sample is lower than 30. Let's do the formula for the z-interval. The z-interval formula looks a little bit different than this on the test or on your formula sheet. The one I gave in class, I kind of prefer it to find my average, is that I'm going to take my average of the sample and do a plus or minus of this, the product of the z-score of the alpha divided by 2 times the lowercase sigma divided by square root of n. This will give me the z interval, or the low bound and the high bound of that. Now the t interval is going to look exactly the same, except instead of your z-score, you're going to be using a t-score. So this would be t alpha divided by 2. And in this case, we're going to have a lowercase s instead of lowercase sigma, because we have less than 30 pieces of data. Now the way that the book gives this formula, and I want to show it to you for the z formula, and you can start to see that this formula is going to actually have some symmetry to it. But on one side you're going to have x bar plus all of this stuff here, z alpha divided by 2 multiplied by lowercase sigma divided by square root of n, and that's where mu is going to sit between that spot and the spot where the x bar is being subtracted instead of added. So you can see where I've wrote it on one side, and it might be better to calculate it this way, but you can see that on the formula sheet we've got our x bar minus our z alpha divided by 2 times our lowercase sigma divided by square root of n. And you'll see that's the same thing for the formula for the t interval. I prefer writing it this way, and if you do compute this left side and then use your average, you can just recall the formula and hit the plus and the minus key to do the problem a lot faster. Now I'm going to use my technology to show you this, so you should copy down these formulas as I do the next 4 problems here. Let's see here. Okay, so let's do 16 and 17, and then we'll go on and do some more stuff with the calculator for 17 and 18. Okay, so it says if 60 animals, well, that's going to be our n right there. So we'll do little marks here. So if 60 animals had an average adoption time of 25 days, there's our x bar, with a standard deviation of 10 days, find the best point estimate, which is another fancy way of saying find mu, and the 99% confidence interval. So that means our alpha is going to be 0.01 interval the population average. Now that also means that since all confidence intervals are two-tailed tests, we got to split our alpha in half, so that's 0.005. So that means when I look this up on the chart, I'm either going to look up 0.0050 or 0.9950. And this is going to give us, if we look at our z chart, and we're choosing z right here because our n is bigger than or equal to 30, if I look at my z chart for these two numbers, I will see that will give me a 2.58. So now I have my, and I want to show you, if you're using your formula sheet and not using my formula up above, this is how you would write it. You're going to have your average, which is 25, minus, and this is our z alpha divided by 2, or 2.56. And then we do our standard deviation divided by the square root of our sample size, and that's going to be less than mu, which is less than 25 plus 2.56, and then what we have is 10 divided by square root of 60. And then you compute this value on the left, and what you get is an answer that's approximately 21.67. You compute this answer on the right, and you get an answer that's 28.33. And that's where mu is between these two. Now, if you're using the graphing calculator to do this entire t-test for you, or z-test for you, the answers are not going to match mine, and I'm going to know that you're actually not doing the formula out, you're just letting the calculator do the work. So be aware of that. If you're just letting the calc do all the work for you instead of doing it yourself, well, that's going to be an issue on the test itself. So don't skip the steps. Now, if we have 10 randomly selected people, so now our n is 10, so we're going to definitely use a t-test, and they were asked how long they worked. The average was 35 hours, so there's our x bar, and then the standard deviation of that 10-person group was 5 hours, so here's our lowercase s. Find the 90% confidence interval, so our alpha is 0.10, and what's nice about the t-tests is that we don't actually have to divide the alpha by 2. The reason why is because when you use a t-test, you can choose the row or column that designates that you have to choose one or two tail test. But when we do a t-test as well, we need not only n, but we need to know the degrees of freedom, because that's how we choose on the left-hand side of the chart, which row we're actually going to use. And degrees of freedom is always n minus 1, so that's going to be 10 minus 1, or 9. So when you go to find, and we're going to use this long formula again, we're going to start off with our average of 35 minus. When you look up your t, alpha divided by 2, you go to the 9th, down from the top, so you go to the row that starts with 9 degrees of freedom, and then you go under the table where it says your alpha of 10% on the 2 tail. And if you do this correctly, you then, oops, drop my notes here. You then get to a spot of 2.898. And 2.898 is going to be the t alpha divided by 2, and then we're going to have in our numerator 5 divided by square root of 10. And the 5 divided by square root of 10, this is our standard deviation right there, as we found here, and there's our square root of the sample size, which is less than mu, which is less than the entire equation over again, but in this case plus 2.898, and then 5 divided by square root of 10. Now if you compute all this out correctly, you get an answer of 32.102, so let's round it to 32.1, which is less than mu, which is less than 37.9. So we're 90% confident that the actual, the interval of their time working is between 32.1 and 37.9 hours. All right, so for our final two problems, you'll note that all this gives us in 18 and 19 is the confidence interval. Hey, we want to find a confidence interval here, but then the big problem is that we need to find out what we're looking for on our what we're looking for in this problem, because we don't have an average and we don't have the standard deviation. Well, that's what the technology's for. So I'm going to freeze the screen here and grab a calculator, and this calculator is going to pop up on the bottom part of our screen, and I'll show you that what I've done is I have typed into list 1 here all the data for this, and I just typed it in one piece at a time. And you're now, instead of finding the standard deviation by hand like we did on the last test, what you're going to do is you are going to type this in and get what you need for your standard deviation and your average. Now, the fastest way to do this is to click the Stat button, then click Right for Calculate, and click 1 for one variable stats. Now, if you have a newer calculator, you'll have to scroll down to Calculate, where it says down here on the middle of the calculator. But these older calculators, you just kind of hit Enter, and there you go. Now, here's the important thing. The average is right there at the top of the screen. No surprises there. But what is going to be a problem is that you're going to have to decide which standard deviation you want to use. Are you going to use capital letter S of x or the lowercase sigma x? And for data pieces under 30, you're going to use this one. So I want to highlight here that this is the average you're going to use for the problem right here. But for your standard deviation for under 30 pieces of data, you use this standard deviation. The one below it is if you have 30 or more pieces. So you can kind of see now why the two formulas differentiate between an American letter for standard deviation and the lowercase sigma for the Greek letter. Well, it's because of that. It's because of that reason that it depends on the sample size which one you use. So we're going to use this 17.5. So I'm going to use my x bar, which is 217.7, and I'm going to use my s of x. Oops. Sorry, that came out a little crooked there. I was writing diagonally. Is going to be 17.5. Now, we know our sample size because our sample size is 10. So our n is 10, and that means our degrees of freedom is 9. And that means all we need to do is figure out what is from the t-chart. We're going to go to 9 degrees of freedom on the chart. And as we go 9 degrees of freedom on the chart, we're now going to see, like, under the 95% two-tail, what that will be as our T alpha divided by 2. And we can see by going to the chart that the 9 degrees of freedom, I want to make sure I'm reading it correctly here, 9 degrees of freedom at a 95% confidence interval of 2 tails is going to put us at 2.262 for our T alpha divided by 2. 2.262. So for our formula, and what I'm going to do now is use the shorter formula where I'm going to take my average, which is 217.7, and then I will go plus or minus, and I'll do one answer for the plus and one answer for the minus, and that will give me my 2.262 times my numerator here, which is going to be my standard deviation, which is 17.5, divided by the square root of my sample size. And if I do this correctly, what I get is 205.19, and I get 230 on the other side, 230.21. Now what I'd like to do for this problem is I'd like to actually go through the calculator steps and show you how I got these two answers. So get your calculators ready and make sure you write down this information, because when I click to type in the calculator on screen here, all this writing is going to go away. Alright, let me type in the formula here, 217.7, and I'll do the minus 1 first. And then that's going to be, in parentheses, 2.262 times the 17.5 is my numerator, divided by the square root of 10 as my denominator. And I'll put two little brackets at the end to encapsulate that. And this is going to give me that lower bound of 215.18 or 19, depending on how you rounded. 118 should be the right way. It looks like I mistyped that when I put it on my answer key. Now what I just did is hit second enter, and I'm going to move the arrow key up to the plus here, and that's going to allow me to do the entire thing for the other side, which gives me 230.22. So being within 1 decimal of the hundredths place is going to be acceptable here. Looks like my answer key was off by 100th, but that is the answer for that problem. Now what we'll do is, for number 19, is we are going to go back to the stat. And what I did is I actually loaded up all the data into another list. So here's the list, data type, excuse me. Here's the list for here. I think it's in list 5. There we go. So this is all of these ages right here of the group, and I want to see, you know, and it says, I'm sorry about, it says cost of these ages. It's probably just for the interval of these ages, so there's a little typo there. But what this is going to allow me to do is the same shortcut, stat right, enter, and again for newer calculators you'd have to go to calculate. What this does, it gives me my average, which is 32.0 in this case. Wow, that's really nice. And I'm going to use my standard deviation of 11. Use my standard deviation of 11. So that's going to be kind of critical when I write this down here to show you what I get. Let's go get the pen out. And now, depending on your rounding, you might get a slightly different answer than what's in the answer key. But let's just write down the critical information. We have 30 pieces of data here, so we're going to use the z-test. And that means that we're going to take our alpha, which in this case is 0.05, and divide it by 2. That alpha divided by 2 is 0.025. So I'm going to look up either the 0.025 on my z-chart, or I'm going to look up 0.9750, and that's going to give me a 1.96 that 1.96, my z alpha divided by 2, is the same 1.96 we had at the top of the worksheet for problem number 14. You're going to find that you're going to use some of the same z-scores throughout the test. So knowing when to cut it in half for z-tests and how to do that is pretty straightforward. So let's look at our work here. I'm going to, unlike the answer key, which said to round your standard deviation to 11, I want to use the raw average of 32, and I want to use the standard deviation in this case of 10.8. And what that's going to allow me to do is to write this formula using the one that I had written down. My average is 32 plus or minus, which gives me my higher and lower bound for my confidence interval. My 1.96 times the quantity of our numerator's standard deviation divided by the square root of the sample size. And I will show you these answers on the technology. And again, make sure to write these down now so you don't lose these when I just click off of this here, because that's unfortunately the byproduct of this software. Alright, so on your calculator we're going to type in, let's go 32, and we'll do the minus first to get our lower bound here. 32 minus 1.96 times the numerator, which is our 10.8, divided by the square root of our sample size, which in this case is exactly 30. And I'll put 2 parentheses on the end. Whoops, not 3, 2. And this gives me a lower bound of 28.14, which again is a little different than the answer key that I have printed out for some of you in class, or maybe you printed out online, because I had you round the standard deviation to 11. Now what I'm going to do is go second enter and change that to a plus, and boom, there it is, 35.86. And that means that we are 95% confident that the ages will be between 28 and 35, or 28.1 and 35.8. So between 28 and 36 is a 95% confidence interval for this range of ages. Well, I hope you found this helpful. If you've got questions about any of this, shoot me an email through your KCC email account, and I appreciate you watching. Thank you.